Welcome everybody to this video in the name of God, the most gracious, the most merciful. So I hope you all are doing well. In this video, I advise you to download the paper Nsc November 2020 Math Paper 1 question, and we're doing question 5. So please follow with me. So they say that the graph of f of x is equal to 3 to the power of minus x. Okay, is sketched below. A is the y-intercept of f. So A is the y-intercept of this graph, which is an exponential graph. Okay. B is the point of intersection of f and the line y equal to 9. So we can tell ourselves that this line here is equal to y is equal to 9. Okay. So before we go to the question, we know this is an exponential graph. Okay. And immediately what I want to put for myself is that I don't want to go to the question yet, but what I want to tell myself is that if I have 3 to the power of negative x, another way how I can write this is y is equal to 3 to the negative 1 to the power x, right? So remember 3 to the power of negative x is equal to y is equal to, in your brackets you have 3 to the power of negative 1, because negative 1 times x is 3 to the power of negative x, negative 1x. So we can separate the negative 1 and the x, and then 3 to the power of negative 1 is also known as 1 over 3. It can also be written as 1 over 3 to the power x. So you can see we have a fraction. Okay, and that value is a is more than 0 and less than 1. That value is a fraction. That's like the a value in our general formula of an exponential graph, and a is more than 0 and less than 1. Therefore, this graph is a decreasing graph. Okay, just like as a side note, because we are busy studying over here. Okay, so this is a decreasing graph, because they can ask you what type of graph it is. So anyway, and I just have to mention that this is another form of how we can write f of x as well. So what's the first question? The first question they ask us, question 5.1. So 5.1 asks us to write down the coordinates of a. So 5.1, write down the coordinates of a. So a is the y-intercept. Okay, so a is the y-intercept, and if you want the y-intercept, you just make x equal to 0 in your normal graph. So if x is equal to 0 over here, if x is equal to 0, a third to the power of 0 is equal to 1. So the y value here is basically 1. Okay, because if you have y is equal to a third to the power of 0, you basically have 1. So the coordinates of a is basically 0 and 1. They ask you to write it down, so you don't have to put the calculation there. Okay. Next question. Determine the coordinates of b. Okay. Now what are the coordinates? Now where's b? Okay, so b, as you can see, is they speak about a point of intersection. Okay, so they say that b is a point of intersection. Now I want you to remember this forever. Intersection. I want you to remember this forever, that when we are busy with a point of intersection, equate the two graphs. So whenever you see a point of intersection, a golden rule is equate the two graphs. Okay, so we have two graphs over here. We got the exponential graph and this straight line graph over here. So the exponential graph is y is equal to a third to the power x. And the straight line graph is equal to y is equal to 9. That's a special line graph. So you just equate those two graphs together. So all that you do is that you say a third to the power x is equal to 9. So you're taking the exponential graph and equating it to that special straight line graph, which is y equal to 9. 9 is that graph, okay? That if that graph would have been y is equal to 2x plus 5, then you would put 2x plus 5 over there. But in this case, it's y is equal to 9, so we just put 9 over there. So we equate the two graphs together and we solve for x. Okay, so how do we solve for x? I'm gonna go, there's many ways we can solve for x, but how do we solve for x here? We can just say, okay, 9, so I'm busy with x in an exponent, so I'm gonna go 3 to the power of 2 is equal to 3 to the power of negative x. So a third is actually 3 to the power of negative x. That was the initial graph that they gave us actually. Oh yes, I could have actually used the, it's fine. That was the initial graph that they gave us, 3 to the power of negative x. You could have even started here with this form of the graph. I don't know why I started with that form. Doesn't matter. Doesn't matter. So anyway, so we have 3 to the power of negative x is equal to 3 to the power of 2. We have the same base, so we can just equate the exponents. Okay, so we got negative x is equal to 2. So divide by negative 1. Divide by negative 1 because you want to get rid of that negative 1. You want x alone, so therefore x is equal to negative 2. Because 2 divided by negative 1 is negative 2. And that is your x value of your point of intersection. Because remember, we're getting the POI, the point of intersection. So we got the x value. So if you want the y value, you just substitute the x value into f of x to get the corresponding y value. So we're going to go y is equal to 3 to the power of negative into negative 2. Y is equal to 3 to the power of 2 and y is equal to 9. No, that also makes sense because b, the y value at b is actually 9 over there. So that was also so you didn't actually have to substitute that x value into the graph. You could just basically see by means of inspection that there's a straight line going from this point to the value 9. So 9 is the y value of b, and the x value that we got is negative 2. So the coordinates of b is negative 2 and 9. Okay. But if you couldn't do it via inspection and you got the x value and you want the y value, remember you would then substitute the x value into any graph to get the corresponding y value. But in this case, we substituted the x value in the exponential graph to get the corresponding y value, and we found out that it's 9, and it is 9. So therefore the coordinates of b is negative 2 and 9. So you put that in for the examiner. Okay, so just remember this day that you must just remember the principle, man. You must just remember the concept. So whenever there's a point of intersection, you always equate the two graphs together. In the exams that you're gonna write, they're obviously not gonna give you the exact same question as this. But the point I want to make is that the principle is important. The principle of point of intersection is just equate the two graphs. You're gonna get marks for that. Don't be scared, okay? So you just equate the two graphs, and then we equated the two graphs over here, and we solve for x. That x is the x value of the point of intersection. If you want to get the y value, you're always going to substitute the x value into the original, into the graph that the point of intersection is on. And that's the exponential graph in this case. And then from that we can calculate the corresponding y value by substituting the x value into that graph to get the y value, and we got it as 9. Okay? Right though. Next question. Write the domain of f to the negative 1. Okay, so I don't know why they ask us that, but anyway, so they say, what is the domain of f to the negative 1? What is f to the negative 1? So the graph that they give us is f. but they're asking us for the domain of f to the negative 1. So I'm thinking that f to the negative 1 is the inverse of f, right? So remember, our general principle is that the range of the original graph becomes the domain of the inverse. So if we can find the range of the original graph, we can get the domain of the inverse. You understand? So the range of the original graph becomes the domain of the inverse. You understand? That you can go back to my videos on how I explain the exponential inverses properties, but that's the general understanding, that the range of the original graph becomes the domain of the inverse, and the domain of the original graph becomes the range of the inverse. So what is the range of the original graph in this case? So remember, the range is all the y values. So the asymptote of this graph, so because this graph has no q value, right? This graph is just e to the power of negative x plus 0. So the q value there is 0. So therefore, the asymptote over here is y is equal to 0. That's 0. So this graph over here lies above the 0 mark, or the 0 point on the y-axis. Okay, so the range of this graph, the range of this specific graph is y is more than 0. Okay, y is more than 0. Okay, because of this original graph, you can see that this graph is only going to lie above the 0 mark on the y-axis. You can see that, right? You can't say y is more than or equal to 0 because this graph will never ever touch this line, this asymptote. So y can never be equal to 0. Now the range becomes the domain. So if the range is y is more than 0 in the original graph, the domain is all the x values. So in the inverse, the domain will be x is more than 0, basically. So the domain in the inverse will be x is more than 0. Okay, so that's just basically my understanding, or basically an easy my understanding of how to get that specific question. Okay, so we got x is more than 0. So that is the domain of the inverse. So the range of the original graph becomes the domain of the inverse. That's just my understanding. You will see that whenever we're busy with range and domain, in my videos I will always explain it using the inverses and not the set builder notation, because I find this method very easier to understand. Anyway, so okay, I'm just gonna stop over here and then we can continue in the second part of this video.